Hello everyone, Stan Su, Technical Director from RIOS. We're a multidisciplinary firm based in Los Angeles with offices in London, Singapore, and Shanghai as well. Thanks to everyone here who put on the event, Boston Valley TerraClad, University of Buffalo School of Architecture and Planning, in conjunction with Carnegie Mellon Institute. It's not my first time here at the workshop, so I'm really happy to be invited back again with the new group. And here to my right I have Mimi Yang, Andy Magner, and Mitch Albaran from Arup, who is our team support, along with Tim Fuller, Irene Martin, and James Chung, who is not able to be here today for the presentation. So I'm pleased to be able to present on behalf of the team, and we'll be fielding all the questions together for you guys. So when we were sort of asked to come, the first thing we did was to come visit the event last year and really kind of just observing the sort of energy that was going on and looking at all the sort of new research that had transpired in the 3 years that I had not been here, and really looking at the, as everyone does, the forming techniques here, and the idea that the research would be to sort of find limits and push the different sort of fabrication techniques to the best of our, application for our project. And so once again, we had the typical assembly methods. In the end, we explored only a couple, which we'll go into later. But the abstract in general was, as you can see here, there's really a system that would be a tiled modular sort of facade system that would allow for inhabitation and sort of interacting with the environment and addressing notions about sustainability, low embodied carbon, operational carbon. These sort of things are ubiquitous to the conversation today with construction in general, and these are definitely things that we thought about, as well as circularity and sustainability in general. And I think in years past we've always focused on holistic designs that focus inwards on the building, and we really want to take that attitude and push it out towards the urban habitat and the larger environment. So in concept design, we had initially started looking at some of our earlier research at RIOS, which dealt with connectivity. And here you see some studies of research that we had done as a group, looking at pollinators and the notion of connectivity. So this is really focused on biodiversity and the notion of how our urban fabric can be sort of brought to better health with gardens, sort of green spaces within buildings. A lot of our work is based in landscaping and master planning, so there's a lot of sort of interest in this with our group. And further that, we're sort of asking ourselves how we sort of push that into architecture and what is the sort of interface there. So this was an inspiration for a lot of the things that we looked at in looking at modular assemblies. Early thoughts about how we could use passive irrigation and as a sort of method of introducing more performance into the blocks themselves, which could serve as sunshades as well. In the end, pollinators, which kind of work to this biodiversity concept, but really trying to find a setting out module that was sort of very flexible, so to speak. And here's some earlier studies of some of our modules where we had essentially a setting out grid, a breeze block, and different modular components like planters and pollinators, which would enhance the facades and add variegation and larger interest. And as well, looking into the notion of systems, right? As we looked at the pollinator and planter units, sort of thinking of different ways in which the modules themselves could be exploited to serve different functions. Here, a lot of the earlier studies looked at more active, I want to say, drainage runnels and whatnot, sort of providing that passive irrigation. We started looking at very simple examples of oyas, which are these vessels that are porous made out of terracotta, which are essentially feeding the soil just through transpiration through the body, and then planter trays, right? So there were these sort of very base, simple notions of what those sort of components could be. And further that, I think when we were thinking about the facade, we really wanted to think of it as a sort of something that the inhabitants would engage. And there's a notion of sort of user-defined activity within this space that can be created between the thermal envelope and the actual facade itself. So in a sense, the space in between the thermal barrier and that screen is actually where we think of as like sort of this major focus point for this research. And in the system development, finalizing on a pattern, we started really honing in on sort of the constructability of this and at a larger scale. What does this mean with a floor-to-floor system where the movements, clearly there is a slab joint that we didn't want to express as a straight line cleaving through these modular units. We can see those red lines there marking the slabs. And so this is sort of the chassis or the framework for the system itself, which invariably is actually two systems. You'll see a more standard rainscreen system that is attached to a substrate, and then one which is purely a porous sort of zone in the middle there that is actually a block unit. So in looking at a lot of these notions of porosity, we really wanted a facade that was inhabitable and had a certain finish to the back of it as much so as to the front. So the notion of a concealed structure was kind of important, as well as continuity in the pattern. And so here you see head sill details, which would have to take up vertical movements, but more or less a stacked system in the middle here sitting on the sill. So rather conventional, the notion of high performance kind of maybe being achieved more so through multiple layers in the building. And this sort of attitude too, that we were sort of even in looking at the system, the notion of eliminating a lot of backer steel structure and aluminum and other components which aren't really considered when we look at sort of embodied carbon. We sort of penalize materials solely on their own rather than looking at the full assembly. So that was sort of a driver in looking at this. And clearly, you know, in the breeze block system here, it's about a 1 foot by 2 foot module, which had to have webbing for stiffening. Here we only have structural elements which are stainless steel pins, whereas the rainscreen requiring an entire sort of base structure, whether that's steel or concrete, substrate, typically here with you know, the girts and the panel clips that hold the rainscreen assembly. So there's a you know, certain simplicity to that breeze block system, right? Here's some analysis, some output from Arup, where they were looking at where the really important sort of failure points were in this, or where we would really focus our attention. And that clearly is in that sort of joint space between blocks where, you know, the notion of a lateral stability was really the cause for, you know, initial studies into the detailed design. And the lateral stiffness was really taken up by this final detail, which was kind of a extrapolation of what we had done in the mock-up. Here you see the typical interface detail, which we're able to achieve enough stiffness in the system and lateral stability that just by using like a type N mortar and some stainless steel pins to resist the rotation of the blocks, that we are able to span you know, upwards of, well, comfortably 7 feet and pushing towards 11 feet we'd like to get to, and we're kind of need to do some more optimization and study on that. But here you see, you know, further development on what the head and sill details would be, and really to allow for the movement between the slabs, utilizing pins up at the top, which would have some sort of hydrometer, barometer such within the hole of the stack block unit that takes the pin just to avoid any sort of local stresses in the concrete itself. And below, it's essentially seated on a similar, at the base detail, a similar sort of assembly as the typical interface, but it has a sort of a more robust plate that is creating this sort of bearing surface there. So a really simple system, and let's see, I'm not able to go further at the moment. There you go. And so looking at, we started looking at performance as well, and we really cited this. We had a site where we placed this at the end of the exhibition corridor, which is actually the end of that one diagram we saw in the sort of connectivity diagram. And this is the west facing, obviously right on the beach. And so looking at the screen and further sort of analysis, typically, you know, the reduction in daylight annual exposure, you know, we're finding that, you know, there's a 75% reduction in the solar exposure on the glazing just from the screen itself. On the left here is the initial sort of location analysis by Arup, which established kind of the values that we used for the daylighting, and then you know, subsequent solar analysis. But we looked at also glare, you know, I think we got down to just above ideal, about around 320 or so. I can't read that perfectly, but that was sort of with the sunshades, reducing it down from 548 lux, getting down to about 320. So it brings it down into a usable sort of range. And as much as we were looking at that performance, we're also looking at sort of plant selection as a means of sort of, you know, the sort of pollinator and aspect of it, sort of looking at the different flora and fauna that can contribute to a healthier sort of biodiverse planting scenario. And here, you know, we're looking at herbs, and, you know, we had selected here, you can see herbs and perennials. Basically, the perennials would attract a lot of these sort of pollinators, and you know, certain notions about low soil and low water needs. The selection was based on that, as well as even the notion of how we could propagate these to allow for better air circulation and whatnot. But so that was a driver in sort of selecting the plants that went into that. And, you know, parallel to this, we were also looking at, I think there we go, looking at sort of the modules in a process of iteration, right? So here we're going through different studies where we're looking at the panelization at first, some few options here, and then eventually, you know, bumping up in scale, looking at sort of the modularity of the planter units and whatnot. Here you see a slightly different geometry, which was optimized later on, and similar to some of the other groups, really pushing this into full scale, just to see what the actual dimensions of this are, and to sort of look at the detailing of it, and thinking about those sort of things. And so the blocks were, you know, quite large. As I said, 1 foot by 2 foot. This is like part of our IFC set, so to speak, where we issued for the end of our sort of research period in March. And this was used by Boston Valley, obviously, to kind of start their fabrication drawing process. When we received the model back, we took that as another opportunity to sort of test things out, in this case, to sequence what our final fabrication assembly method would be. And yeah, I mean, this is a quarter scale printout, or I say 1 to 4 printout, which is actually full. There's no glue in this thing, even those little clips actually you just clip in by friction. So it was really good for us to kind of like stage how we were gonna do the actual assembly. And once again, taking that model and a lot of coordination back and forth and fine tuning the pieces. And so that was a useful process. Having that kind of resolution in the model was really helpful. And as with all things research, there was a lot of questions about how these these modules would react in drying. You know, these really large modules, there were some concerns about differential shrinking and those sort of things are all taken into account, but because of such a large scale unit, I think it was a bit of a test in and of itself what would happen. The rainscreen panels you see there on the rack, ready to get fired with glaze, those are in fact all slip cast as the blocks were for this exercise, but the notion is that the blocks could be ram pressed or extruded for the best efficiency. And these rainscreen panels as well would be sort of ram pressed just based on their geometry on the face. So here's a picture of the group here, sort of getting to the workshop on the first day and really seeing all the pieces that we got and sort of making adjustments on the fly and really kind of starting with the sill detail and essentially building 2 columns up, which were then restrained at the top. And you can see a close-up here of the block, but this is essentially, was a pretty easy process. You can see here we have epoxy shims. We did not grout this assembly for the sake of the mock-up, and you will notice that some of these units are foam. But I think we certainly got all of what we needed to out of the blocks that were terracotta. Here you see the group working on the actual block assembly as well, prepping some of the planters. Picture of Andy Brayman, who is cutting these rainscreen pieces, so the offcuts, and you know, getting really good results with the Italian saw. Very precise and hardly any chipping at all, as you could see. And this is something we know from past experience, but it was really great to kind of just do that all at the workshop on site. And here you see one of our team members, Mimi, were preparing this planter unit. So this is the inner shell of the unit, which is meant to be unglazed to absorb the water freely from the glazed sort of lower vessel, which would act almost as like a vessel. So taken away from some of the earlier ideas of the Oya and the planter tray and the really base level functionality, let's say. And picture Ravina, one of the student helpers that we had from CMU, and as well thanks to Yannick from Waterloo for giving us a hand on the blocks as well. A little quick time lapse here showing the group the kind of the speed of this, which just was going, it almost exemplifies how fervent the work was really. A lot of activity in a short span of time, and at one point we didn't know if we were going to finish, but hats off to the group. It was incredible. I'm really proud of what we did in the face of adversity. And here we see, just sort of the activity that went on with that. And so at the end, we did finish on time, and we were able to get this thing outside. And one of the aspects that we were really curious about was that like I said, that living facade, and the ability of this facade to actually create an environment within that interstitial space that was highly inhabitable. And oftentimes you look at these spaces and they're very sort of solemn, and they're not well lit. And really, in this one, it was interesting because we didn't go to a glaze that had any sort of noticeable reflectivity to it. In fact, some of these units that you can see are unglazed completely. Some have sort of glaze on the inner, and then this sort of salmon color body that you see up there. That was meant to be a actual through body, unglazed salmon body color. And I think when we sort of looked at the back and we caught some of the light coming through there, we were pretty pleased at the effects that we were getting, and we were getting little bees coming and checking out the plants, so that was cool. But yeah, I think this was full of surprises, and not all of them were great, but the ones at the end were really good. So we were really happy to sort of have that little struggle. And so here's a the rendering of a potential living space. Here would be sort of a residential application where one could open up operable glass doors and really even extend this terrace space into like an interior space and promote a sort of different sort of, I guess, attitude to living and not dominated by sort of like all glass views and whatnot. And so, we'll end with these shots. These are, I think, pretty evocative for us. We're excited to see where this might go. And with that, I'll end with the shot of the group. So thank you.